Hi, I'm Isaac, a tutor at CWI. Today I'm going to be working through a problem from Practice Exam 2 for Physics 212. The problem is number 8, and it states an initially charged 10 microfarad capacitor, this guy right here, 10 microfarad, is discharged from a voltage of 10 volts to 5 volts. So the voltage initial, or V sub 0, is 10, and the voltage that it's being discharged to is 5 volts. And it's being discharged through a resistance, R. So some value resistance in a period 4 seconds after the discharge began. So in other words, in 4 seconds we went from 10 volts to 5 volts. So that's 4 seconds for time. Alright, so I'm planning on making a video about deriving charging and discharging equations for capacitors. But for now I think it's probably most important that you just have this, which is for discharging, and then also have the charging capacitor equation written on your cheat sheet. Okay, so using this equation we already know some things. We know that V we discharge to 5 volts, that the initial voltage we started with is 10 volts, e to the negative t over RC. Alright, so let's go ahead and divide both sides by 10. And what we end up with is 1/2 equals e to the negative t over RC. And we're going to go ahead and take the log of both sides, which is going to get rid of the e. The e and the log are going to cancel, so the natural log of 1/2 equals negative t over RC. Now, ultimately, what we're trying to find is the, for part A, is the time constant. Now, tau is equal to RC. We know what capacitance is, we don't know what resistance is, but it might be good to make a substitution here. If tau equals RC, why don't we just erase that and put tau down here? Because ultimately we're going to have to solve for tau first and then use it to extrapolate the resistance. Okay, so the next step is we can solve for tau by multiplying it over. Tau equals, and then dividing ln over. So that's tau equals negative t over ln of 1/2. Let's go ahead and plug that into our calculators. T is 4 seconds. So we've got negative 4 over ln of 1/2. And what I'm ending up with is a tau of 5.77. Now the units of tau are going to be ohm farads, because it's R times C, so ohm farads. Turns out it cancels out to seconds, so tau is a unit in seconds. And we'll talk about that more in a minute. So here's part A. Tau is approximately 5.77 seconds. There's A. Now B asks us what the resistance is, and once we know tau, which we just solved for, we can go ahead and plug it back in to our tau equals RC. We want to solve for resistance, so we'll divide by capacitance. Resistance equals the time constant divided by capacitance. Now capacitance, it's important that we put this in farads. We were given a 10 microfarad, and to convert we would just times it by 10 to the -6th for micro. I'm just going to go ahead and move the decimal places. As you can see, the decimal started here, 1, 2, 3, 4, 5, 6. So now we have capacitance in farads. We know tau, so we'll take tau, which is 5.77, divided by capacitance in farads, 0.00010, and that's going to, that's going to give us tau. That's going to give us resistance. That's what we're solving for. Alright, so 5.77 divided by 0.00001 is going to give us a value of 577 kiloohms. And so that's our answer for part B. And now I'm going to do just a brief segment about what tau represents. So tau is a very important approximator, and so tau does equal RC, but what it represents is kind of graphically what the exponential charging and discharging functions look like. So for this particular problem, we started with a particular voltage at a particular time 0, and that voltage was 10 volts. So that's 10 volts at time 0. And then we decayed over the period of 4 seconds. Now we calculated tau to be 5.77 seconds. So I kind of want to show you graphically what that represents. So if we go 1 tau, 2 tau, 3 tau, 4 tau, and 5 tau, go ahead and write those out. These are multiples of the time constant. And what's agreed upon in the electronics community is by the time you've reached 5 tau, your capacitor is entirely discharged or charged, depending on which way you're going. We're working with discharge. So the time it took was 4 seconds to get from 10 volts to 5 volts. So from 10 volts to 5 volts took a little bit less than a time constant. So there's our time, which is 4 seconds, a little bit less than 5.77. And what you'll notice is this curve looks something like this. And by the time you get to 5 tau, it doesn't mean that you're entirely discharged. It just means that the amount of charge on the capacitor is negligible. So a way to check our answer is, by the time you get to 1 tau, you've approximately had a discharge of 63% of what you had. And so 63%, you've lost 63%, which means you have 37% left. So if we take 10 volts and times it by 0.37, that gives us 3.7 volts, which means that at 1 tau, we're going to have 3.7 volts. So at slightly less than tau, we have 5 volts. That looks logical. It fits the curve. And so that's one way to check with the 5 tau method. Each tau has a related percentage. For tau, you will have 37% left if you're discharging, or 63% charged if you're charging. So there's one method to double check your answer. I hope this was helpful, and let me know if you got the same answer.